when it comes to transportation, it comes to civil engineering, everything else has changed. So what do I mean by everything else? Well, what they call it now is disruptive change. When I first saw that word, I thought that was a bad thing, but no, disruptive is good disruption. It's changing everything we do. It's the electrification, it's all the technology I'm going to talk about. It's disruptive change, and as an engineer and being in technology and being in transportation right now, this is probably, it's got to be one of the most exciting times. I don't know, maybe when they went to cars from horse and buggy, that was pretty exciting, but aside from then, this has got to be the most exciting time to be in that field because it's changing so fast, the acceleration. So what do I mean? So even starting with planning, and I'm happy to hear it at the Caltrans that we have engineers and planners actually working together. But it was easy. It was level of service. You know, it was something that engineers could figure out. Well, it's not level of service anymore. Now it's vehicle miles traveled, VMT. Do we widen? You know, that was the answer to everything was widening. You know, I was once in charge of the long-range plan for the state of Missouri, and we had a North Star plan that literally showed the state of Missouri with all the state routes either made to 4-lane or 6-lane. And it was just silly, but that's what engineers were doing. They weren't planning. They were just widening everything as soon as money became available. That's gone, especially here in California. Funding, gas tax, well, that's not going to work because more and more we're driving cars that use electricity and we're not paying gas tax. So what are we going to pay for it with? Not sure. We talked about traffic. You know, we mentioned ITS, Intelligent Transportation Systems. That's where it's really kind of gone berserk, and I'll explain some of that later, but we don't have loop detectors anymore. The project that I'll talk about later, we don't have loop detectors. We're going to video cameras, which record 24/7, 365. We have sensors, Bluetooth sensors, so that we can keep track of the traffic, see where it goes. We can do planning. We can do origin destination studies 24/7. If there's an event in town, we can say who's traveling to it. Where are they traveling from? Where are they leaving and going to? It's just a different world that didn't even exist 10 years ago. What we're starting to implement here in the Coachella Valley today. Now this is one I almost didn't put in, but complete streets is something that we ignored for a long time. We as engineers anyway, maybe not so much the planners. But we ignored complete streets. We forgot about pedestrians, we forgot about bicyclists, and we focused on the automobile. And now we find ourselves retrofitting everything to accommodate them more safely and more enjoyably. And the funding is followed. There's a lot of federal funding, a lot of state funding here in California especially, focused on complete streets. So it's change, it's something different. Connected and autonomous vehicles. So what does it take? You know, as an engineer, I've never heard of that when I graduated, and I've had to learn. But you know, it needs roadside units, which are radios, and it needs them frequently placed. Striping, even. That's kind of an unfunded mandate. It's stripes in California on their system is now 6 inches wide instead of 4 inches wide. Well, that's 50% more paint. Nobody's providing funding for 50% more paint. V2X, vehicle to infrastructure. I'll bet you if you have a new car in the last 2 or 3 years, it's got technology on cruise control. It's probably ready to talk to signals or getting, you know, maybe next year's model. It's here, and we're implementing it in the Coachella Valley. So this isn't some far-ranging thing. It's here now. Smart cities, you hear about it, you read about it. It's based on the transportation network. It's based on the fiber optic that we'll put in the ground. It's based on the equipment that we put at signals. It's the Internet of Things. It's smart lighting, smart watering, smart parking. You know, you name it. If there's infrastructure, you can make it smart by connecting it to everything else. And largely, that's being done through transportation, even broadband access. You know, we talk about access, about how it's, you know, highways and roadways are access. Well, broadband is access too, and guess what? Broadband is now part of transportation networks. Mobility as a service, MOS. You've seen the Ubers and Lyfts, and you've seen the push that's coming towards not owning your automobile. You'll use your automobile as a utility. You'll pay some monthly rate like you do for your electricity or for any other service you have, and you'll access your vehicle to travel. It's coming. It's here. It's in pilots all over the country. It's even been implemented in a few places. Talking about employment, so here in the Coachella Valley, so you always think of the Bay Area or San Francisco or San Diego, LA, maybe the East Coast, but it's here in the Coachella Valley. We're implementing these things right now, and it'll be real in probably about 2 years. Point about employment is that here come up trends in engineering. We already have 2 cities that don't have a PE, professional engineer, in charge of public works. That didn't exist 30 years ago. That didn't exist 20 years ago. But it's a trend, and you'll kind of see why. There's no city, with the retirement of a gentleman in Palm Desert very soon, there will be no city in the desert with an in-house traffic specialist. They all use consultants for that function because it's become too technologically advanced to keep on board a full-time equivalent staff and pay their retirement and pay all their benefits. It's become too technical for cities. That didn't exist 30 years ago. So talk about our signal synchronization project. And it's to synchronize signals, make traffic flow better. But really, it's the foundation for all the rest of those things I talked about. It's the foundation for smart cities. It's got planning measurement tools and tracking tools. We've got the ability to count pedestrians and bicycles 24/7, 365, which will hopefully result in better projects, better planning, better access. But this project is really, and it's valley-wide, with maybe one exception, but it's valley-wide, and it's here. And we're actually trying to go to construction sometime this calendar year still, in the first phase. Again, as engineers, when I graduated, we were taught to be a mile wide and an inch deep, that top bar. It's not to scale, by the way. And then when we need to, we dig down deep, because we know how to use the resources. And so what do I say for now is start digging if you're graduating. And for the universities that are teaching these kids what to do, you're going to have to understand land use and planning better than you did, because those are aspects of civil engineering and aspects of transportation. And you're going to have to dig. We're going to have to dig in communications. Good Lord, I never thought I would be having to learn about wireless and fiber optic, broadband, 5G. Does anybody know that 5G, for 5G to exist, there has to be fiber optic backhaul. So again, that fiber optic that we're putting into our networks is part of 5G, which isn't really here yet. Small cell towers. Those are the towers that communicate with your cell phones and with lots of other infrastructure. In 20 years, we've built 800,000 small cell towers in this country. We'll have to build 2 million more in the next 5 years. So it's going crazy. And so Internet of Things I talked about. Revenue. This isn't the gas tax. This is monetizing these assets. If you've got broadband placed throughout your city, throughout your county, well, you can sell that broadband. You can monetize those assets and help pay for some of that. Again, cities, counties, state of California, Caltrans, they hire consultants to do a lot of this work because it's become too technical for them to employ internally. Public sector's an open book because, again, the push is towards not having PEs. You better understand engineering. You better understand how things work together in systems. But like I said, you have to start digging lots of more trenches to find out what you need to know in communications, autonomous vehicles. You know, I talk about our signal synchronization project, but at a conference I was just at, one of the speakers says that he goes to the Consumer Electronics Show every year to see what the cutting edge trends are. And in the last couple of years, it's been autonomous vehicles. But this time, it wasn't cars anymore. It wasn't trucks. It was drones. And it wasn't drones for carrying Amazon boxes. It was drones for carrying people. And that was the hot new thing. And I just saw an article, even I think yesterday, on a drone that carries 2 people, has 36 motors. It's the Jetsons. I mean, that's an autonomous drone, I think, that they have in the picture. And we better start being ready for it, making sure that our infrastructure has anticipated it.